Hello class, this is your flip video for elements, compounds, and mixtures. So you should be filling out your whisk. Again, that is writing, watching and writing, okay, summarizing, and questioning. So we're going to talk about elements, compounds, and mixtures. Before we get started, we need to go over these vocabulary words. We have pure substance, element, and atom. You've heard some of these mentioned before, and during this video you're going to hear them mentioned quite frequently. But I want to make sure that we have a common definition so that you know what I'm saying when I say element or atom or pure substance. So first, pure substance. Okay, pure substance is any sample of matter. Okay, it's matter that has definite chemical and physical properties. Okay. Pure substance is a matter that has definite and chemical and physical properties. Water is a pure matter, or pure substance. The element carbon is a pure substance. So this is a wide range of stuff that it can be, but know that it's matter that has definite chemical and physical properties. Okay, an element, we've talked about the periodic table of elements. Today we're going to talk about what an element is. Okay, an element is a pure substance. So again, pure substance. An element is a pure substance that can't be separated into simpler substances. Okay, by physical or chemical means. It's a pure substance that can't be separated into simpler substances by chemical or physical means. This you should know. Okay, what's an atom? I'm waiting for your answer. What's an atom? Hopefully, you should have said it's the smallest unit of matter. Okay. It's the smallest unit of matter, but now that we're talking about pure substances and elements, we're going to add to that. So we're going to expand our definition. An atom is the smallest unit of matter that maintains the properties of an element. Okay, hopefully you can see that. Okay, an atom, the smallest unit of matter that maintains the properties of an element. So, now that we know what an element is, okay, we have a periodic table of elements. We have over 100 different types of elements. How many types of atoms do you think we have? We have the same number of types of atoms as we do types of elements. The smallest unit of matter that maintains a property of an element. So, for example, let's go back to carbon. Carbon is an element. We can have a carbon atom. Hydrogen, we've talked about that, is an element. We can have a hydrogen atom. Okay, oxygen, another element. We can have an oxygen atom. So again, pure substance, matter that has definite chemical and physical properties. An element is a pure substance that can't be separated into simpler substances, and an atom is the smallest unit of matter that maintains the properties of an element. So we went from broad to very focused, big to tiny. Our next topic, molecules. Okay, molecules are composed of two or more elements that are joined by chemical bonds. Okay, they're composed of two or more elements that are joined by chemical bonds. You guys have seen this in my room before. Okay, this is a model of a molecule. Okay, molecules aren't this big. Okay, this is a model. Each one of these represent an atom. Each one of these little balls represent an atom. The black ones are a carbon atom. The white ones are hydrogen atoms. Okay? So it's composed of two or more elements that are joined by chemical bonds. Okay? They're joined by composed of two or more elements that are joined by chemical bonds. So this molecule has two elements, carbon and oxygen. Okay? We can do this. This is still a molecule. Okay? It's composed by two or more atoms. We have two hydrogen. This is a molecule. Okay? So the elements can be the same, or they can be different. Okay, if we have a molecule where elements can be the same, like oxygen gas, we'll have oxygen, but we have two of them, so we write it O2. Okay, if elements can be different, okay, and I'll use this model as our example. Okay, we have carbon and hydrogen. So we have carbon and hydrogen. We have two carbons, 1, 2, and 6 hydrogens. Okay, so both of those are molecules. Compounds. Okay, a compound is a pure substance composed of two or more different elements joined by a chemical bond. Okay, the key word here is different. Okay, pure substance composed of two or more different elements. So my example before, O2, oxygen gas, is not a compound because they're not different elements. Okay, but the other example, the C2H6 that I showed you, would be a compound because it has carbon and hydrogen, which are two different elements. Okay, so compounds are, an example is water. Okay, H2O. We have hydrogen and oxygen. Okay, hydrogen and oxygen. Compounds can only be separated by chemical means. There has to be some type of chemical reaction for a compound to separate. Okay? So only separated by chemical means. They have their own chemical and physical properties. Okay, they have their own special properties, like water, for example, has its own properties. It boils at 100 degrees, it freezes at 0. Okay, that's a special property of water. But it has its own chemical and physical properties. Okay. And also, their properties are different than the elements that make them up. For example, hydrogen is a gas. Oxygen is a gas, but when they combine together, they make a liquid. Water is a liquid. So their properties, the properties of the elements, are different than the properties of the compound. Mixture. A mixture is a combination of two or more pure substances that are not chemically combined. So before we talked about substances that had chemical bonds, there was some type of chemical reaction that forced those two elements together, those atoms together. Now we're talking about mixtures. These are combinations, so again, they're things that come together of two or more pure substances, but they're not chemically combined. Okay? Do you think it's going to be easier to separate a mixture because they're not chemically combined? Okay. You should have answered yes. Okay. If something is not chemically combined, that means that we can do things physically, which is a lot easier to do than chemically. We can do things physically to separate those mixtures. Okay? So again, it's a combination of two or more pure substances that are not chemically combined. Okay? They're held together by physical forces. Okay, they're held together by physical forces. No chemical change takes place. So there's been no chemical change. Okay. Each separate item has its own properties. Okay, each substance has its own properties, and they can be separated physically. Okay. You can separate them physically. So again, it's a combination of two or more pure substances that are not chemically combined. They're held together by physical forces. No chemical change takes place. Each substance has its own properties, and you can separate it physically. So let's think of an example. Let's think of a salad. Okay? Would you say a salad is a mixture? Okay? Two or more pure substances. We have lettuce, that's a pure substance. Onion, another pure substance. Tomatoes. Okay, carrots. Okay? We mix that all together, we have a salad. We have something new. But we can still pick out all the separate parts. We can pick out the lettuce, we can pick out the tomatoes, we can pick out the onions. Okay, we can pick out carrots. Okay, there's been no chemical change. We didn't make anything new. Okay, all this stuff is still there. It's just now combined together. Okay, each substance has its own properties. That lettuce is still lettuce. Okay, that carrot is still a carrot. Nothing's changed. And again, we can separate it physically by physically picking out those pieces. Okay, are all mixtures as easy to separate as a salad? No, there's some mixtures that you have to do a little bit more, but you can still separate it by a physical mean. Okay, we have two types of mixtures, homogeneous and heterogeneous. The first type we're going to talk about is homogeneous. Okay, I want you to look at your root word. Homogeneous, or word parts, homogeneous. We have the word part homo. Homo means same. Okay, so we're going to be looking at stuff, talking about the same stuff. So these molecules are mixed up in an even distribution. Everything in a homogeneous mixture looks like it's one thing. It all looks the same. Okay, we have two types of homogeneous mixtures that we'll talk about. We have solutions and colloids. We're going to talk about briefly about solutions today. We're going to talk about more in depth in your next video. But solution, okay, it appears to be one substance. Some examples are salt water. Okay, when you go out into the ocean, can you pick out the little parts of salt, or can you see the little parts of salt? You can't. Okay, it looks like water, but we know there's salt in it. We can take the salt out of it, okay, which makes it a mixture. But it's a solution because it looks like one substance. Other examples are lemonade, Kool-Aid, soda. Air is a mixture. Okay, air is made up of a bunch of different gases. but we can't see and separate all those gases, so it's a solution. Okay. Colloids. It's a different type of homogeneous mixture. It's a mixture of tiny particles that are bigger than those in a solution, but smaller than in a suspension. A suspension, we'll talk in the next board. A suspension is a heterogeneous mixture, but these are homogeneous mixtures. So basically, a colloid is an in-between. It's a homogeneous mixture because it still all looks like one thing, but the doesn't quite as evenly distribute as a solution. Okay. So we have solutions examples. Okay, salt water, lemonade, Kool-Aid. What were some other examples, or what can you guys think of? Okay, I want you to write that down in your list under the examples. Colloids. Okay, examples of colloids. Milk, mayonnaise, okay. Whipped cream, okay, these, you know it's a homogeneous mixture and not a heterogeneous mixture because it does not settle over time. Those parts will still remain and will still look like one substance. You won't see milk separate, or you won't see the mayonnaise separate unless there's been a chemical change. Like if milk starts to go bad, it's because there's a chemical change, then you'll start to see separation. But until then, it all looks like one substance. Okay. Our last slide, heterogeneous mixtures. Again, our word part, hetero. Okay. Hetero means different. So these are going to be mixtures that are not evenly distributed. Okay? Molecules are not mixed up in an even distribution. Okay, the one we're going to talk about is suspensions. Okay, a suspension, a type of heterogeneous mixture, is a mixture in which particles are dispersed in a liquid or gas and will eventually settle out. Okay, some examples. Snow globe. Muddy water. Okay. Sand in water. So if you take a snow globe, okay, we have two things. We have water, or that liquid, and then we have the little tiny things that look like snow. Okay, we mix it up, and then we have that snow distributed throughout the water. But what happens when you set that snow globe down on a desk or table? Okay, eventually, all those little particles will float to the bottom, okay, and it will settle out. It becomes separated. We have the liquid on top and then the particles below. The same thing with muddy water. Okay, we get mud, dirt, and water. We mix it up. Okay, it mixes up. The mud is throughout the water, but eventually the mud will settle to the bottom and the water will be on top. Same thing with sand and H2O, sand and water. Okay, if we shook up my fish tank, okay, so that algae that's been growing on the bottom that you guys think is gross because I haven't cleaned it yet, but that fish tank, we shake it up, we can distribute that algae throughout, but over time it'll go again settle to the bottom. Okay, so just to recap, we introduced a few new concepts. Okay, so you're going to want to go over these notes a few times, probably rewatch the video. We expanded our definition of an atom to include that it is the smallest particle of matter that still retains a property of an element. We talked about what an element was. It was a pure substance that can't be divided any further without losing its properties. We talked about pure substances. Compounds. And compounds are two or more elements combined together. I'm sorry, that was molecules. Forget that. Okay. Molecules. Two or more elements combined together. A compound is two or more different molecules combined together. And then we have mixtures. Mixtures are pure substances that are combined together, but not chemically. They're combined together physically, which means they're easy to separate. In class the next few days, we'll look at how we can separate mixtures, the differences between compounds and mixtures, and we'll do a couple labs so you guys can see that. But make sure to go through your WISC, summarize, and question before you come to class. Okay? I'll see you guys in class.